ready to start. It's my great pleasure to introduce Professor Kosuke Imai from Harvard University. Professor Imai is in the Department of Government and Statistics, and his research spans seminal work in decision-making, topic modeling, causal inference. And even though I'm a statistical geneticist, I need to say that I found a lot of inspiration reading his social science work for my own work. So it has a lot of far-reaching implications broadly beyond the social science field and statistics. I'm very excited to hear this talk.
Yeah, thank you. Thanks, Bianca and Laura, for organizing this conference. I was looking forward to visiting Princeton, where I taught 15 years, but now I missed that chance. So this work, so I was, when I was asked to present something on this topic, I decided to just do causal inference, because that's the missing data problem, and something that I'm most excited about, which is something I'm currently working. So this project is with my co-authors, Jito Jiang, who is in the UMass Amherst, and a couple of my colleagues at law school, Harvard, and my graduate students, so on and so on. Okay, so sure this works. Okay, so there's a lot of statistics, machine learning, and artificial intelligence in our daily lives that's being used quite a bit these days. Nothing really new, but this speed has accelerated due to technological advances. So you've seen this everywhere in the media and elsewhere. Okay, so but the motivation of this project is to realize that humans still make many consequential decisions. We haven't automated everything yet. And this is true even when the human decisions can be very suboptimal, we still make decisions. We may want to hold somebody rather than something accountable. So there's an argument to be made, even if you're not good at making decisions, we might still want to make those. So that's what I call computer-assisted human decision-making, where humans make decisions with the aid of machine recommendations. So routine decisions are made in this way by individuals in daily lives. We can think of online shopping and some other things where we get some recommendations from machine, but we still make the choice. Okay. However, the consequential decisions are also made in this way. And in particular, judges and medical doctors get a lot of information from some algorithms, and then they still make the decisions. So the question I'm interested in is, how do machine recommendations influence human decisions? Do they help human decision makers achieve a goal? Do they help humans improve the fairness of the decisions? So the key, I think, here is to look at the impact of machine recommendations on human decisions, rather than just studying the machine recommendations themselves, because at the end of the day, humans are the ones who are making the consequential decisions. So this is sort of one complaint I have, I think, in the literature on algorithmic fairness, is that they focus so much on the fairness and accuracy of machine recommendations rather than how they impact human decisions. So we're going to develop a set of statistical methods for using experiment to evaluate how algorithms affect human decision making. The application that we're going to look at is something called the Pretrial Risk Assessment Instrument, PRAI. Machine recommendations actually turns out to be often used in US criminal justice system. The particular instance we're going to focus on is something called the first appearance hearing, where judges make the two decisions: whether to release somebody who got arrested, who is pending the disposition of criminal charges, and if so, what condition, what amount of the bail to impose, or any kind of monitoring condition if they're released. Okay. So the goal here is to avoid the predispositional incarceration while preserving the public safety. So on one hand, if you release someone who is danger to the public, poses a danger to the public, that's not a good thing, but you don't want to hold everybody in jail, especially because they're not yet being charged with crimes. Okay. So judges are required to consider 3 risk factors along with others. Arrestee may fail to appear in court. So if that's the case, you might want to keep the arrestee in the jail. Arrestee may engage in a new criminal activity if they're released. Actually, some of them still engage in such activities with, even when they're in custody. And they might be particularly concerned about the violent criminal activities. So PRAI is a machine recommendation to judges. Basically, they give some numerical scores for each of these dimensions. How likely it is for arrestees to fail to appear in court, for example. Okay. So they classify these risks, arrestees based on these risks. And it's derived from application of a machine learning algorithm that's often proprietary, so you don't really know what algorithm they use, or statistical model, to training data set that's based on the past observations. So there's, some of you may have heard like a lot of controversy over the potential racial bias of these scores. So ProPublica did analysis and published about potential racial bias of the COMPASS score, which is one of the most used, most popular PRAI that's available. And then the company that creates this COMPASS score wrote a rebuttal. But what we want to emphasize again is that this is the bias of the score itself. And it doesn't really speak to the question of how these scores affect judge decision. In particular, judges may have their own biases, whether it's a racial or gender biases, and the scores themselves have their own biases, and then they may interact. So it's very important to analyze the impact of these scores on the decisions, not just the properties of the score itself. Okay. So one thing was unfortunate is by 1 week, I missed the deadline where like I can make the results publicly available. So there is a field experiment that's current, we've analyzed, so we finished analyzing, but still waiting the permission to make the results publicly available. So unfortunately at this point, I cannot really say where the experiment is being conducted and what the results are, but I try to do my best to give you a sense of how these results may look like. In a couple of weeks, if you check back my website, there'll be a paper with the real empirical results. Okay, so in this county, there's PRAI is being used based on the preliminary criminal history and age. There's 2 separate ordinal risk scores for FTA failure to appear and NCA new criminal activity, and then white binary score for NVCA, new violent criminal activity. Okay. Judges have other information about an arrestee in addition to PRAI. And so there's a bunch of information that judges may have that we don't have access to, so the researchers don't have access to. Okay, so we've conducted a field experiment in the real world. So the Clark assigns case numbers sequentially as cases into the system. So cases arrest. PRAI is calculated for each case using the computer system. And if the first digit of case number is even, PRAI is given to the judge. Okay, so essentially the provision of PRAI is randomized over these different cases. So in some cases, judges see these scores. In the rest of the cases, they don't. And that way we can figure out how the provision of these scores impact judge decision. And this was done in the real cases. It's not artificial experiment. Okay, so here again, the data I cannot release. Unfortunately, it's like 2 more weeks, then I would be able to. But so there's somewhat empirically informed synthetic data set to give you a sense of what it looks like. So it's an ordinary score for FTA and NCA. And the higher the number is, the higher the risk. And then there's a binary score for the violent activity. And you can see we categorize the judge's decision into 3 categories. Signature bond is the least, most lenient decision, and then the amount of cash bond is imposed, different amounts of cash are imposed. And in this synthetic data, you can see that there's some impact of these criminal activities where for example, if you look at the NDCA, you might see that the proportion of signature point is somewhat less when it's equal to 1 as opposed to equal to 0. Yeah, so that's basically so these numbers are actually the judge receive when they are making a decision. Okay. So obviously we can do intention to treat analysis given that provision is randomized or semi-randomized. And we can look at what's the impact on judge decisions. And as you can see overall, if you give a PRAI, the judge seems to give harsher decisions relative to the more lenient decisions. And you can do this for across different groups of RSTs. So there's a large effects on judge decisions. However, if you look at this, on this side, on the right side, you see that if effect on the actual outcome, so failure to appear or new criminal activity or new violent criminal activity is very, very small. Okay, so it seems that this effects is having a big, the provision of the PRAI seems to having a big big impact on the decisions, judge decisions, but there's no impact, very little impact on the outcome, the behavior of RSTs after the decision. So this is strange, but right, because judge's decision is going to have a big impact. For example, if you are kept in jail, you're more likely to appear in the court. So that's unlikely. So there are some heterogeneous effects being masked, right? So judges are making decision non-randomly on the different RSTs. And so how that mechanism interacts with the effect of provision is probably masking the effects. So there's a lot of effects, heterogeneous effects that exist, but on average, it looks like there's no impact on the behavior itself. So what we do is sort of unpack, so go beyond the ITT analysis, standard ITT analysis, and then unpack this effect a little bit more. Okay, so you can think about, say, there are n cases. Zi is the binary variable which represents whether PRAI is given or not. Di is the judge's, say, binary decision. For now, we can generalize this to other settings, but for now, for simplicity. So either you release or detain. And the outcome is the binary outcome of these three variables of interest. Okay, and then there we observe some covariates about RSTs. We can think about the potential outcome. So this is where the missing data comes in. The potential value of the release decision, right? So judges could release, judges have different decisions based on, depending on whether the PRAI is given. And then there's the potential outcome, which is a function of both the judge's decision as well as whether the PRAI is presented. Right? So if you're familiar with causal inference, the problem is that we only observe one of the many potential outcomes. So we don't know what the judges would have done if they weren't given the PRAI for a particular case where a judge actually received that PRAI. So we have to sort of think about what are the counterfactuals. And we can maintain the assumptions, randomized treatment assignment, and we're gonna assume exclusion restriction, that is the PRAI provision doesn't affect the outcome, affects the outcome only through the judge's decision. So this is reasonable because the arrestee don't know whether the PRAI is given or not. Okay. We also make assumption that if you're detained, if you're released, you're more likely to commit a new crime, or no less likely to commit new crime compared to whether you're detained, when you're detained. So these are some three assumptions that are reasonable in our current setting. So the causal quantitative interest is something based on what we call principal stratification, and that's paper by Frangakis and Rubin. basically think about what would happen if the decisions are different. So here, y of 1, y of 0 is whether you commit a new crime if you're released versus if you're detained. Okay. So so this means that you commit a new crime if you're released, but you won't commit a crime if you're not released. So these are the preventable cases. Now, there are risky cases where you would commit a crime anyway, like you might commit a crime in the prison as well, or safe cases where you don't commit a crime regardless of whether you're released or not. Okay, so these are the cases that you can think about, but unfortunately, you won't know which case you're in, right? You only observe under a particular decision what you have done. You know, if you're released, we observe what you did when you're released, but we don't know what you would have done if you weren't released. So that's basically the missing data problem. Okay. By monotonicity, we eliminate the last case where you only commit the crime if you're detained. So now we can decompose this ITT effect of PRAI provision on the judge's decision among these cases. Okay, so you can say, what is the effect of PRAI on judge decision among the preventable cases? What is the effect of PRAI on judge decision among the risky cases or safe cases? Okay. So if PRAI is actually helpful, we should see the negative effect for the preventable cases. Okay. So because the preventable cases, you want to detain these people. And in the safe cases, you want to release. So if the actually PRAI is helpful, we should observe that. Okay. And what to do with a risky case depends on what you know is. Okay. So partial identification in the paper, we derive the bounds, and we show that sign of APC, these effects are identifiable if we make those three assumptions. Now, point identification requires additional assumptions. So for, in particular, we assume that given the PRAI and covariates we observe, decision is independent of the potential outcome. So this is similar to missing at random type of assumption in a missing data context. Okay. So this assumption would be violated if judges have the information that we don't have. And then I told you about there's some information that judge may have that we don't have access to. Okay. Then in the paper, we developed the sensitivity analysis. Okay. And once we make this assumption, there is identification results. So you can sort of show that you can use the weighting to identify these effects, the decomposed effects that I showed you earlier. Okay. In the paper, we extend this to the ordinal decision. So judge's decision is typically ordinal, like you impose bail amount. So you know, I talked about binary decision setting, but that we generalize that to ordinal case. I guess I don't really have much time, so I'll just mention that. And we're also thinking about multidimensional decisions. So you can think of monitoring condition is another part of the decision, not just the bail amount. And so you can think about how the PRAI impacts on multidimensional decision. Okay. One thing I want to mention, last thing I want to mention is something called principle of fairness, which we have a separate paper. So there's a growing literature that focuses on the fairness of machine recommendation PRAI. As I said, we need to think about you know, how the PRAI, the provision of it, improves the fairness of the judge's decision. But we're going to look at the focus of, you know, fairness of the decision itself. Existing statistical fairness definitions don't take into account how a decision affects individuals. So there's no causality in there. They're just looking at the observable. So principle of fairness have this idea that decisions shouldn't statistically depend on the protected attribute like race or gender within the principal strata. Okay. So among the risky cases, the judges shouldn't be discriminating blacks and whites and men and women. Among the safe cases, judges shouldn't be discriminating different gender, different race. So that's sort of the new fairness condition that we introduced in this paper. And that's different from the existing one because we condition on the principal strata. We condition on unobserved principal strata, and then require that decision be independent of race and ethnicity within those similar cases. So the idea is that if the decision, the people who are affected similarly by the decision should receive a similar decision. So that's basically sort of intuition, regardless of your background. Okay, and then we can talk about how this PRAI provision affects the fairness of the judge's decision. Okay, so all that is in our paper. But I'm gonna skip that because these results not real data based on synthetic data. Okay, so to conclude, we offer a set of statistical methods for experimentally evaluating computer-assisted human decision-making and application to this pretrial risk assessment instrument. This is the first field experiment ever conducted, since the last one was done in a small experiment back in the 80s. Most of the experiment has been like online, hypothetical, artificial experiment. This is the experiment actually involving the real judges and the real RSTs. Okay. Actual empirical results will be made public in a couple weeks. So we're thinking about extension to multidimensional decision, optimal PRI provision. That's different from optimal PRAI. Effects of PRAI on judges and RSTs over time. We have some follow-up data that we can use. And there's a couple papers that are related available on my website. So I'll stop here. Thank you.
Thank you very much. I actually have a question for you regarding your presentation. I was wondering, so in cases where some attributes might be overrepresented than others, how sensitive is this framework to not biasing data, but just like not unbiased sampling techniques? And is there a way that you have thought to mediate that problem?
Yeah, so in the particular experiment we are conducting, we basically have all the cases that came to that particular court. It's a county level, sort of lower level court, so the crimes are not, mostly petty crimes. Yeah, but obviously, if you sample some of these particular cases, but that are not representative, then the conclusion might be different. In our framework, we sort of focus on conditioning on the principal strata. So like, for example, in the fairness condition, we say condition on the principal strata, decision should be independent of the race, but obviously there are some other covariates as well. So you might want to, condition on like income or maybe ties to the community and other things that are also correlated with the race. So in this paper, in the archive, we have like causal model that sort of shows when this type of causal sort of fairness condition is equivalent to the statistical definition, which is just focus on independence on the observables. And you can show that if you condition a particular set of covariates, then those are all equivalent. So, it all depends on the causal model, like, which covariates to condition on, that kind of decision. If you know the causal model, then you don't have to condition on all the covariates. In fact, if you condition on some wrong covariates, you can get the wrong conclusion. Yeah, so it's sort of, you have to think about, I think one of the important thing about this is that You know, when you talk about fairness, we shouldn't just focus on the predictive accuracy. We should think about like causal, you know, model that arises to these issues. Like if you think about, you know, like slavery, that's, you know, historical process is affecting how people perceive or how people act for different races and so on. So I think it's really important to have the causal model, and based on that, you try to make some decisions.